Hello, friends. We are going to talk about the most powerful storm in the solar system, one that even a spaceship cannot escape. The Great Red Spot on Jupiter is a high-pressure storm located in the southern hemisphere of the planet. Its diameter is more than 30,000 kilometers, which is enough to fit two Earths. Scientists have been observing it for centuries. But what do we really know about this mysterious phenomenon? What new discoveries await us? And how can we protect ourselves from the terrible power of the Great Red Spot? In this video, you'll find out. The Great Red Spot is one of the most striking features of Jupiter. It's a gigantic anticyclone with speeds reaching 640 kilometers per hour. The first recorded observation of the Great Red Spot dates back to 1878. At that time, it was already quite large, covering an area larger than the Earth. Since then, astronomers have been tracking its behavior and have seen how it changes shape and size. For example, between 1995 and 2009, the storm almost disappeared from the surface of Jupiter. Some experts even suggested that the Great Red Spot would disappear altogether. However, the spot reappeared again, although it's now even larger than before. And no one can explain why it keeps coming back. In fact, the Great Red Spot is just the tip of the iceberg of a much larger vortex. The diameter of the entire vortex is about 140,000 kilometers, which is equal to about 4 Jupiter diameters. But only the central part of it has a bright red color. The rest looks like a pale oval shape with darker stripes along the edges. The inner part of the storm moves counterclockwise, while the outer part moves clockwise. And the speed of these currents can reach 180 kilometers per hour. That means that on Jupiter, unlike Earth, the winds blow faster than the speed of sound. The air pressure inside the Great Red Spot is enormous. It's about 22 times higher than the Earth's atmospheric pressure. And that's why even spaceships can't get through to Jupiter's surface. No wonder the Great Red Spot has been raging for over 350 years. There isn't anything that could stop it. This storm occurs due to differences in temperature and speed between the upper and lower layers of Jupiter's atmosphere. Hot vapors rising from the depths of the planet form clouds of ammonia ice. They float up to the upper atmosphere where they cool down and turn into liquid. These drops fall back to the lower layers and form powerful winds. As you can see, the Great Red Spot is just a consequence of normal processes occurring on the planet. Just on Jupiter, everything is much more intense than on Earth. Speaking of intensity, scientists distinguish several zones on the Great Red Spot. The central one is relatively calm. Here, the wind speed is lower and there are fewer clouds. On the contrary, outside the central zone, there are strong winds and thick clouds. This is where the most powerful thunderstorms in the solar system occur. Their height reaches tens of kilometers, and their power is thousands of times greater than that of ordinary earthly thunderstorms. Lightning strikes within the Great Red Spot are 5 times more frequent than on Earth, and the energy released during them is 300 times greater. Jupiter's moon Io serves as a source of energy for these storms. It ejects sulfur and oxygen compounds into space, and they become the nuclei of electric charges. Then lightning strikes and powerful X-ray flashes occur. All this generates a huge amount of energy that heats the upper atmosphere of Jupiter. And then the cycle repeats again and again. The Great Red Spot is also notable for the fact that it produces its own light. Indeed, in addition to being a huge storm, it's also a real source of light. This is because the gases and dust particles contained in the clouds reflect sunlight. The brightness of the Great Red Spot is so great that it can be seen even with the naked eye. But besides the reflection of sunlight, the Great Red Spot emits its own light due to the fact that the ascending air currents heat up and glow. This process is called adiabatic heating. When air rises rapidly, it expands and cools. If the air continues to rise, it will eventually begin to glow brightly. This is exactly what happens in the Great Red Spot. Air currents rise very quickly here and reach enormous speeds. That's why the Great Red Spot shines so brightly. Another interesting feature of the Great Red Spot is its color. Why is it red? This question has long puzzled scientists. but they have some theories. One of them is that the red color of the Great Red Spot is due to the presence of phosphorus in its atmosphere. Phosphorus is a white substance that turns red when heated. It's possible that the Great Red Spot heats up the phosphorus in Jupiter's atmosphere so much that it acquires a reddish tint. Another theory is that the red color of the Great Red Spot is due to the presence of organic compounds in its atmosphere. These compounds are formed as a result of the interaction of methane with sunlight. Methane absorbs ultraviolet radiation from the sun and breaks down into hydrogen and carbon monoxide. Carbon monoxide then reacts with oxygen to form carbon dioxide and water. Water evaporates and forms clouds. Meanwhile, hydrogen and oxygen form a hydroxyl radical, which can react with other organic compounds to form complex molecules. These molecules absorb red and infrared light and reflect it back into space, giving the storm its characteristic color. And finally, the third theory is that the red color of the Great Red Spot is due to the presence of sulfuric acid in its atmosphere. Sulfuric acid is a strong oxidizing agent and can easily react with phosphorus and other organic compounds present in the atmosphere of Jupiter. This reaction can lead to the formation of colored compounds that give the storm its red color. Scientists still haven't figured out which of these theories is correct. However, they all agree on one thing: the Great Red Spot is a truly unique phenomenon that helps us better understand the processes occurring on our gas giants. Jupiter doesn't have a solid surface, but it has many layers of gas and liquid. The Great Red Spot is the largest of the vortices in the atmosphere of Jupiter. Its diameter exceeds the size of 3 Earths lined up side by side. The depth of the Great Red Spot reaches several kilometers. It appears as a high-pressure zone surrounded by high-altitude jet streams. The outermost of these streams flows in the opposite direction from the Great Red Spot and acts as a barrier preventing it from expanding further. The Great Red Spot is home to Jupiter's most violent storms and most intense lightning. The pressure in the storm is high enough to crush any spacecraft that dares to enter it. It's about 28 times higher than the atmospheric pressure at sea level on Earth. The atmosphere around the Great Red Spot contains a lot of water vapor and other gases, which creates an almost continuous fog. This makes it difficult for spacecraft to observe the storm directly and hampers the study of the planet's surface. In order to learn more about the Great Red Spot, NASA launched the Juno interplanetary station to Jupiter in 2011. The probe made its first close-up photos of the Great Red Spot in 2017. They showed that the storm is even more vast and complex than previously thought. The resolution of these images is so high that scientists can see the evolution of the storm in detail. They also learned that the Great Red Spot is deeper than previously thought, extending more than 3,000 kilometers below Jupiter's cloud tops. Inside the storm, there's an area with unusually calm winds. This part of the storm is surrounded by fast winds moving in different directions. The calm winds may indicate that the Great Red Spot is actually a giant vortex of fluid deep inside Jupiter. Scientists believe that the Great Red Spot has existed for hundreds of years and will continue to exist for millions more. Despite its colossal size and age, the Great Red Spot is not the only storm on Jupiter. The planet has many other vortices, including smaller ones that appear and disappear over time. Some of these vortices are similar to tornadoes that occur on Earth. Others resemble giant hurricanes that can cover entire continents. Jupiter's moon Io is the main source of energy for the planet's storms. It constantly ejects gas and dust into space, which creates an electric field that causes lightning and powerful magnetic fields. These magnetic fields interact with the solar wind and the moons of Jupiter to generate powerful currents in the planet's atmosphere. These currents cause strong winds and form giant vortices. Studying storms on Jupiter not only helps us better understand the planet itself, but also sheds light on the processes occurring on other planets in the solar system and beyond. By studying Jupiter's storms, scientists hope to learn more about the origin and evolution of the planet, its atmosphere, and its interaction with the solar wind. The Great Red Spot is a truly amazing phenomenon. Its colossal size, incredible speed, and unique color make it one of the most fascinating objects in the solar system. Studying the Great Red Spot allows us to better understand the processes occurring on Jupiter and other gas giants. Perhaps in the near future, we'll be able to unravel all the secrets of this mysterious storm. And who knows? Maybe one day we'll even be able to use its power for our own needs. And now, I'm waiting for your comments below the video. How do you feel about the fact that such a terrible storm exists in our solar system? Be sure to subscribe and put likes. And also don't forget to watch other videos.